When we talk about wood as a sustainable building material, I think it's helpful to take a big step back and just think about the fact that wood is a natural material that's all around us. It's very plentiful, and we can use it to build the things that we need. And then it can regrow many times over the course of our lifetimes. It can be a much more sustainable solution because it's low embodied carbon, meaning fewer carbon emissions associated with manufacturing it and constructing it. And then in the end of life, when the building is deconstructed, there's lots of possible next uses for that material. The other big benefit about mass timber is the amount of carbon that it actually stores. So as trees grow, they absorb carbon from the atmosphere, and they store that carbon physically in the wood fibers. We can harvest those trees and continue to store that carbon in our cities, in our built environment, while still letting the next generation of trees grow and absorb carbon dioxide from the atmosphere. When we start talking about forestry, I think that's where we start getting a lot of questions, and rightfully so. We all want to make sure that we're doing the right thing when we're specifying wood as a building material. The sustainable forestry practices in place in the United States involves regeneration, it involves replanting trees, and harvesting in a sustainable way. It might sound counterintuitive, but countries that have strong wood products markets actually have healthier forest ecosystems. And that is because landowners have an economic incentive to keep their land forested. When we want to make specific environmental claims about wood products and wood buildings, this is where we turn to life cycle assessment, or LCA. And this is where we look at the entire life cycle from the very beginning, extraction or harvest of the raw materials, through the manufacturing process, transportation to site, constructing the building itself, using the building, and then decommissioning it at the end of life, and determining what happens to those materials at the end of the building's life. When we talk about it in the context of a whole building, we can do a whole building life cycle assessment, or a WB-LCA. We can also do a life cycle assessment on an individual product. And a lot of times these product level LCAs are summarized in what we call an environmental product declaration, or an EPD. This is what a lot of designers are turning to right now to better understand the impacts during manufacturing of the individual building materials. The International Standards Organization, ISO 21930, walks us through a life cycle assessment and all of the life cycle stages, including biogenic carbon. And it defines for us that any time biogenic carbon enters our product system, it's categorized as a -1. That is a carbon removal from the atmosphere. Now, when biogenic carbon leaves the product system, either through a direct export of material or through direct carbon emissions back to the atmosphere, that's counted as a +1, so it comes out the other side. So throughout each life cycle stage, there will be small emissions associated with product leaving our system, but at the very beginning we had a very large negative, and that's the carbon that's physically stored in that wood element.